Hello everyone, this is a 2-mark question from GATE 2005 where a program is given in C programming language and asked to find the result of this particular code program segment, and along with this code segment they also give these 4 different output option. Clear? So what will be which one of these 4 different output will be the correct one? We need to find out that particular output. Clear? So let's start. Again, program starts execution from main function. That means we first system will create a memory block for main function, and in this main function, in this memory block that is created for the main function, 2 variable will declare. One is a, another one is sum. That means one variable is declared with name a. This a will contain 2048, and one more variable is there, that is sum. The variable name is sum, and sum contains initial value 0. Clear? Now the next instruction. Next instruction is function called foo. That means from this main function, a function called foo is called with argument a and sum. That means from this main function block, what is the value of a? The value of a is 2048 and the value of sum is 0. Clear? Now control switch to this particular function call. The function call is foo with parameter a and sum. So the value of a is 2048 and the value of sum is 0. That means this is our function call. Now what happened? Now system will go to the function call. So where is this particular foo function is defined? This particular foo function is defined here. Clear? Now, and when control come from main function to this foo function, at that time the argument is 2048 and 0. That means 2048 and 0. This 2048 will be received by n and the 0 will be received by the variable sum inside the foo function. That means from here control come to the foo function, and in foo function we have 2 variable n and sum. Both are of integer type, so integer n comma integer sum. Now in this particular memory instances, the variable n will initialized with first argument, that is 2048, and the second argument, that is 0, will be stored in sum variable inside the foo function. Now after receiving both the arguments, the control entered inside the function definition, and first instruction is int k equal to 0 and j equal to 0. That means in this particular memory instances, system allocate 2 memory block for variable k and j. So let's do it. Here in this particular function definition, we also have one variable with name k initialized with 0 and j again initialized with 0. Now the next instruction is if n equal to 0. What is the value of n here? The value of n is 2048. That means, is it 2048 equal to 0? Is it true? No, that is not true. That means this particular instruction will not execute and control come to this particular instruction. So what is this particular operation? This is a modulo operation. So what is the value of n? The value of n is 2048. So 2048 modulo 10. That means 2048 modulo 10. So what will be the remainder of this particular operation? The remainder of this, look, the operation is 2048 modulo 10, and this modulo operation always gives us the remainder. So when we divide 2048 by 10, what will be the remainder? The remainder will be 8. 8 will be the remainder, And what will be the quotient? Quotient will be 204. Clear? So we will get, in this particular, while system execute this particular instruction, at that time the result will be 8, and that 8 will be stored in k. That means now the value of k will be 8. Now the next instruction. What is the next instruction? The next instruction is j equal to n divided by 10. That means now the value of n is 2048. 2048. Now 2048 is divided by 10. Now what will be the result? The result will be 204. So this 204 will stored in variable j. That means the value of j will update to 204. Clear? Now the next part. Next part is sum equal to sum plus k. Now what is the value of sum here? The value of sum is, now the instruction is sum equal to sum plus k. Now what is the value of sum? The value of sum is 0, and what is the value of k? The value of k is 8. That means now it is 8. So what is the result? Result will be 8, and this 8 will be stored in sum variable. That means the content of sum here will be 8. Clear? Now the next instruction. Now look at here. In this particular foo definition, we again call the function foo. Clear? Now from this particular function definition, we again call the function foo with parameter j. Now what is the value of j? The value of j is 204. So here it will become 204, and the next value sum. What is the value of sum? The value of sum is 8. Now the value of second parameter is 8, and the first parameter is 204. Now what happened? What system will do? From this particular block of foo, control jump out and enter into the foo block once again. Clear? Control jump out, control come out from this function definition and again re-enter to the function definition, but in memory in a new instance of foo definition. Clear? That's why that is what it makes difference. Clear? So from this foo definition, again control enter inside the foo definition and create a new memory block for this foo definition. So here I take it that side. From this particular point, control come out here and create a new foo block with now again integer n and integer sum. Now what is the first parameter? The first parameter is n, and the second parameter is sum. The first parameter is n, the second parameter is sum, but the value is 204 and 8. So here 204 will store and sum will contain 8. Now inside this foo block, n is a variable that will hold the value 204, that means first parameter or first argument, and sum is one more variable that will contain 8. Now enter inside the function definition. Inside the function definition, first it will create a variable k with initial value 0. Second variable it will create j with initial value 0. Now come here. In this particular instruction, the value of n. What is the value of n here? The value of n is 204. Now is it equal to 0? No, it is not equal to 0. That means what system will do? System will go to the next instruction. Now the n. What is the value of n here? N modulo 10. What is the value of n? N is 204 modulo 10. It will give us 4, and this 4 will store in the variable k. That means this 4 will store in the variable k. So the value of k will be 4. What is the next instruction? The next instruction is j equal to n divided by 10. That means j equal to n divided 10. So what is the value of n? The value of n is 204. 204 divided by 10. Now look, we are not in the main block, we are not in the first instance of foo function, we are in the second instance of foo function. Look, the variable n along with second instance of foo function, it is also available in the first instance of foo function, but in first instance of foo function it contains 2048, but in the current instance of foo function it contains the value 204. So it is very important where we are currently in, that means in which instance we are currently working. That is very important in case of recursive function call. Look, this from the function definition of foo function, we are again calling this particular foo function, that means it is a recursive function call. So, and in recursive function call we must have to deal with the memory part. We must have to explore the memory part to execute or to find the correct result. Clear? So let's do it. Now the value of n is 204, and 204 divided by 10, that means it will give us 20. This 20 will store in the variable j. Now the variable j will contain 20. Now the next part. What is the next instruction? Next instruction is sum equal to sum plus k. So next instruction we get it sum equal to sum plus k. What is the value of sum? The value of sum is 8. What is the value of k? The value of k is 4. So what will be the result? The result will be 12. Now this 12 will store in the sum variable. Now this 12 stored in the sum variable, and the content of sum will become 12. Now what is the next instruction? The next instruction is what is the next instruction? The next instruction is again foo. Again we are calling foo from this particular foo instance. Now I am writing it in this here. Now foo function is again called with parameter j and sum. Now what is the value of j? The value of j is 20. And what is the value of sum? The value of sum is 12. That means two argument is 20 and 12. So from here its control of program execution come out and re-enter in the foo function. Clear? That means from here one more foo instance will create with 20 and 12 as parameter, integer n received the first parameter, integer sum receive the second parameter. Now in this particular block again first parameter is received by variable n, sum is the next parameter, sum variable receive the next parameter, that is 12. Now we enter inside the foo function again in this particular foo instance. So first it will create two variable k and j. So k will initialize with 0 and j is again initialized with 0. Now next instruction is if n, the value of n is 20, not 20 equal to 0, is it true? No, it is not true. So system directly comes here, and the instruction now is k equal to n modulo 10. So what is the value of n? The value of n is 20 modulo 10. So what will be the remainder here? Remainder will be 0. Now this 0 will store in the variable k. So k will again hold 0. Now the next instruction is j equal to n divided 10. Again the value of n is 20, 10. So 20 divided by 10, what will be the result? Result will be 2. Now this 2 will stored in the variable j. Now the value of j will updated to 2. Now the next instruction. The next instruction is sum equal to sum plus k. So what is the value of sum? The value of sum is 12. What is the value of k? The value of k is 0. So 12 plus 0 means 12, and it will again store in the sum variable. That means sum variable again contain 12 only. Now the next instruction. In next instruction we are call the foo function. So from this foo instance we again call the foo function with parameters j and sum. So what is the value of j? The value of j is 2 and the value of sum is 12. Now from here control. From here control come out from the foo function and re-enter into the foo function. That means in memory it will create a new block for foo function, receive the argument with variable integer n and integer sum. Now in this particular foo instance, what happened? In this particular foo instance, the first argument is 2, 2 is received by n, so the content of n will be 2. The second argument is 12, 12 is received by sum, that means the content of sum is 12. Now we enter inside the function block. So k, a variable is declared with k and j, that means k is initialized with 0 and again j is initialized with 0. Now the next instruction. What is the next instruction? Next instruction is n equal to 0. So what is the value of n? The value of n is 2. 2 equal to 0, is it true? No, it is not true. So it will come here. Now in this particular instruction, k equal to n mod 10. What it will give us? Look. What is the value of n? The value of n is 2. 2 modulo 10. What it will give us? It will give us 2 as result. Now this 2 will be stored in the variable k. Now the content of k will become 2. What will be the next instruction? What is the next instruction? Next instruction is j is n divided by 10. That means n divided by 10. What is the value of n? The value of n is 2 divided by 10. What it will give us? It will give us 0. Now this 0 will store in the variable j. This result will store in the variable j. Now the value of j will be 0. Now the next instruction. The next instruction is sum equal to sum plus k. So what system will do? Look. Sum equal to sum plus k. What is the content value of sum in this particular instance? The value of sum is 12 plus the value of k is 2. So 2 plus 2, that means 14. Now this 14 will store in the sum. Now this sum the content of sum will update it to 14. Now the next instruction. The next instruction is again a function called foo. The function foo is called again. Now from this instance, foo function is called again with parameters 0 and sum, j and sum. So what is the value of j here? The value of j is 0. And what is the value of sum here? The value of sum here is 14. Now what happened? Control again come out from this particular instance and re-enter into the function definition of foo function itself. That means again a new block will create this foo function. So we are doing it here. Foo int n comma int sum. Now in this particular instance, what happened? The first parameter, that is 0, will received by variable n. The second parameter, that is 14, will received by the variable sum equal to 14. Now the next instruction inside the function body. Now the next instruction inside the function body is declare two variable k equal to 0 and j equal to 0. So in this particular instance, first one is k. So first variable declared is k, initialized with 0. Second variable declared is j, initialized with 0. Now the next instruction. What is the next instruction? Next instruction is this if condition. Now what happened? Now look, if n equal to 0, what is the value of n here? N is 0. So 0, now it encounters 0 equal to 0. Is it true? Yes, it is true. So when it is true, which instruction will execute? This particular return statement will execute. That means now system encountered this return statement. That means in this particular instance of foo function, now the return statement comes. System encounter the return statement. Return statement. Now what happened? When system encounter this return statement, where it will return? It will return to the previous instance from where this particular instance gets called. That means we encounter the return statement in this foo instance. Now from where this foo instance is called? From this particular foo instance. That means the previous instance. So from this function instance, when we return, at that time it will return to the previous foo instance. Now when this return statement encounter, the control return to this particular foo instance, and this particular memory block will deallocated. Now no longer it will available in the memory. It is deallocated totally. Now we are where? Now we are in this particular foo instance. Now in this particular foo instance, that means we are in this particular foo body, but where, in which instruction? Now we are in this return statement, in this foo function, because this particular foo function, this particular foo instance is created when this particular foo function call is occurred. That means when we return back to this particular instance, at that time we will return to this particular instance only. Look, from this function definition we can return either here or we can return here. Clear? We have two options to return. When this particular return happens, at that time we will return, at that time we will return to this particular function itself only. Clear? Now we are here, and when we return in this particular position. And what will be the next instruction in this particular instance? Look, in this particular instance, or for this particular instance, we already executed all the instructions and the function is called from this particular instruction. That means whenever control return back to this particular function after execution of this particular instruction, at that time it will return to this particular to this particular instruction only. Clear? Now from where it will execute, it will restart the execution. It will restart the execution only after the instruction that is present below this particular called function. Clear? Next. So what is the next instruction? The next instruction is this one, that means printf. Now we are in which memory instance? We are in this particular memory instance, and in this particular memory instance we are printing the value of %d, the value of k. So in this particular instance, what is the value of k? The value of k is 0. Let's write down all the output here. So it will execute this particular instruction and the value of k is 2. That means here it will print 2. Clear? Now it encounters the closing brace. So where it will return? It will return back to the previous instance from where this particular instance called. That means it will return to the previous instance from where this function is called. Clear? Now after getting this closing brace, it will return to the calling of the previous instance. In previous instance, from where this particular instance gets called, at that particular position it will return. That means here in this particular instruction. So now this memory is deallocated. Now we are in the next instruction. We are in this particular foo instance, that means in this particular code segment, and we are in this particular instruction. Now what is the next instruction? The next instruction is printf, this one. So in this particular memory instance, what is the value of k? The value of k is 0. That means it will print 0 next. Now again the closing brace encountered. That means from this particular instance also it will come out and go back to the previous instance. So now this memory will be deallocated. Now what happened? In this particular instance, we are in this particular instruction. In this particular instance of foo function, we are in this particular instruction. Now what happened? Now system will execute the next instruction. What is the next instruction? Print the value of k. So in this particular instance, what is the value of k? The value of k is 4. So next it will display 4 here. Clear? Now again closing brace encountered in this particular instance. That means again it will return to the previous instance. So from where this particular instance get called, it gets called from this particular instruction. That means now this memory is deallocated and controlled back to this particular instruction. That means we are again in the foo function. We are again in the foo function, but in foo function we are in the foo function call. So in this foo function we return back to this particular instruction. Now what is the next instruction in this particular instance? In this particular instance the next instruction is printf instruction. So what system will do? System will print the value of k, whatever value in this instance, whatever value for k in this particular instance, system will print that particular value. So what is the value in this instance? The value is k equal to 8, k equal to 8 is here, that means it will print next 8. Now again, after completion, after execute this particular printf instruction, the closing brace occurred, that means it will return from this particular statement. So from this particular instance it will again return. So now where it will return? Now look, from here this particular foo instance get called, from main function. Now that means now from this closing brace it will return back to the main function. Clear? Now here it is not cleared properly, but in the memory instance it is absolutely cleared. So this is the reason why memory instance is important in case of recursive function call execution. So from this foo instance, system again return to the main function, and in main function where it will return to the foo function call. So control back to this particular instruction and now it will return. Now look, when it come back from this foo instance, this particular memory block is deallocated, point to be noted. So now we are in the main function. Now inside the main function we are in this particular instruction, and this execution of this particular instruction is completed. Now what is the next instruction in main function? The next instruction in main function is this printf instruction. Now our system will print the value of printf %d, the value of sum. Now what is the value of sum in main function? In this main function the value of sum is 0. Now look, in this particular foo instance the value of sum is 8. In this foo instance the value of sum is 12. In this foo instance the value of sum is 12. In this foo instance the value of sum is 14. In this foo instance the value of sum is 14. But we are not displaying the value of sum from any of the foo instance. We are displaying the value of sum in the main function, but we update the value of sum in the foo instances, but we did not update the value of sum in the main function. Look at the code. Look at the given code set in the main function. Here no updation operation is performed for the main function, for the sum variable. Whatever the initial value in main function, that value we are going to display here. We did not update the value of sum. So when in the main function the printf instruction encountered, the value of sum is 0. So here it will display 0 next. So and then all the instructions of main function is executed and closing brace encountered in the main function. That means control come out from this main function and execution of this program is complete. Now the execution of the whole program is completed. All the memory is deallocated. Whatever memory used by the system to execute this particular program is already deallocated. Now what result we get? The result is 20480. That means which one is the correct result? First one is 8. Is it the correct result? No, it is not the correct result. In next option B is again 8. So it is also not the correct result. Now C and D. In C the result is 20480. But here the result is 20480. That means this one is also a wrong option. So the result is 20480. That means option D is our correct answer for this particular given problem. So hope you understood the whole program execution and how we find out this particular result. So that's it for this class. See you soon in our next class. Thank you.